Hello everyone, welcome to YourPedia Education. So today we are going to discuss the past paper of BEL. So basically, as you know, the BEL released the notification of 350 vacancies. Out of these 350 vacancies, 200 vacancies are for the electronics candidate. That is a good opportunity. If you are pass out and you are trying to find a good government job, then BEL is a very good opportunity for you. And if I am talking about that is not through gate, they are taking their own exam. So you can prepare for that exam. So YourPedia is going to launch a module on 15. So if you are want to try, if you want to prepare for that exam, you can join our module, right? So we are going here to discuss the past questions asked by the BEL. So it is a paper which is last time BEL asked for that exam, right? Okay, the number of branches, the first question is from the control system. There are total number of questions are 100 questions. If I am talking about the technical background, there are 100 questions. Out of these, most of the questions are from the communication part, control part, network part, right? In this exam, basically, if I'm talking about the BEL exam, you have to more focus on the communication, signal part, right? Network, right? So lots of the questions are coming from these subjects, right? So first, we will start the question that the number of branches of a root locus is equals to, आपकी जो branches है वो किसके equals होंगी, of a open loop transfer function, right? Open loop transfer function. See, basically if I'm talking about the root locus branches, so root locus will start from where? Root locus will start from the pole and it will terminate on a 0. So if I'm talking about a proper transfer function, he is asking about the proper transfer function. Proper transfer function which is having the number of poles is higher than the number of zeros, right? So if the number of poles is higher than the number of zero, then the root locus branches are equals to the finite number of poles. So what is the answer for this question? The number of poles, right? So basically if he is asking about the root locus branches, the root locus branches are equals to the number of poles for a proper transfer function. If it is not a proper transfer function, then it will decide by the 0 or poles, which one is the greater, right? Next question. Right. Which is the correct regarding the Fermi level in the semiconductor at 0 Kelvin. 0 Kelvin पे semiconductor के अंदर जो Fermi level होगा वो क्या होगा? See, basically if I am talking about the Fermi level inside the semiconductor, right? Inside the semiconductor at 0 Kelvin, this is our conduction band. This is our valence band. And at 0 Kelvin, the Fermi level will always lie in between these two bands. Means you can say that at the center of these two bands, right? So center is lying EF at 0 Kelvin. Because at 0 Kelvin, you know that your semiconductor will behave like a insulator because all the electrons and holes are bounded, right? All the electrons are available in valence band. No electron will be available in conduction band at 0 Kelvin. So basically at 0 Kelvin, your Fermi level is lying between the middle of the conduction band and the valence band. So what is the answer? D is the answer. Fermi level in an intrinsic semiconductor lies between conduction band and the valence band, right? It is not lying in the, see, it is not lying lying on the top, not lying on the bottom, right? Next question, if I'm talking about, right, here is the detail you can check. I already mentioned the everything, right? What is the main advantage of double sideband suppressed gradient modulation over conventional AM? See, if I am talking about conventional AM and DSB and conventional AM both have the same bandwidth, right? There is no change in the bandwidth. So he is asking what is the main advantage? Main advantage, we suppress the carrier. If I am talking about the AM signal is what? AC 1 plus kf ka mt cos of 2 pi fct. See, basically this is your AM signal. That is called conventional AM signal. If I am talking about the DSB signal, the DSB signal is AC MT cos of 2 pi fct. This is your DSB signal. If I compare these two signals, there is no bandwidth change. Bandwidth of AM signal and DSB signal are same. But main advantage of DSB signal is that the power consumption of DSB signal is lower than conventional AM because we remove the carrier part. If you completely write it, that is the carrier signal plus Ka message signal into the carrier signal. So basically if I remove this carrier, we will left with the DSB signal. So most of the power in your AM signal will carry by the carrier power, right? So if you remove that carrier, so power consumption of DSB will become lower. So what will be the answer? Answer will be D. Okay. Next. What is the main characteristic that distinguishes white noise from other type of noise? See, basically if you are talking about white noise, what is the meaning of white? White means, see, if you have a white light means it is having all types of colors inside that one. So same thing, if I am talking about the white noise, the power spectral of the white noise S and F with respect to F is constant, that will be N naught by 2. So the white noise will affect all the frequencies with same amount. That's why we are saying it's white. So what will be the answer? It has a constant power spectral density. That is the graph of the power spectral density of a white noise. So if he is asking about the white noise is generally a noise which is having a constant power spectral density, or it is affecting all the frequencies with same amount. That's why its power spectral density is constant. So what will be the answer? Answer is D. Right. Next is, in digital communication system, increasing the SNR, what will be? See, basically in your digital communication system, Q of SNR, I'm generally writing, there are several things, that is proportional, the probability of error, or you can say the bit error rate. Bit error rate is directly proportional to the Q function of SNR. Q is always a decreasing function. Q function is always a decreasing function. So as your SNR increases, bit error will be decreases. As your SNR will be increasing, see, basically if you have a decreasing function, let us take, I have a decreasing function like this. If I increase the value of this x, so what happens? The value of this function will decrease. It means the probability of error, or you can say the bit error rate, will decrease as your SNR will be increasing. So in this way, from this formula you can check it like this, or another way you can think about this. If you increase the SNR, means you increase the signal quality, right? Noise will be lesser as compared to signal. So basically there is a less chance of error. So that's why the error in bit will decrease. You can think about this from this one, or either you can think about this from the signal to noise ratio, because signal power will increase, noise power will decrease when you increase the SNR. So if I increase the SNR signal power, so it means your signal quality is higher at the receiver side. That's why it is having less error inside your signal, received signal. In a two-port network, if Y11 is the short-circuited input admittance, then Y21 parameter represents what? See, basically, if I am talking about this question, the equation, see, you can see here, the equation of, equation of Y parameter is what? I11 is equals to Y11 V1, Y12 V2, I2 is equals to what? Y21 V1, Y22 V2. See, if I'm talking about this, we have a system like this and two-port network. Basically, it is two-port network. So basically, if you have a two-port network, let us take V1 is the voltage here, I1 is the current inside this, and similarly V2 is the voltage here, I2 is the current entering inside this two-port network. So basically this equation for I1 and V1 is the voltage for input port 1 and port 2 voltage V2, current I2. So basically he is saying that the Y11 is what? He is saying that Y11 is, Y1 is short circuited input admittance. Then he is asking for Y21. Y21 is what? This is. So basically, if you short circuit, because we are doing the V2 is equals to 0. V2 is equals to 0. When will be the V2 equals to 0? When you short circuit this. If I short circuit this, then it is also short circuited, right? When your V2 is 0, then it is short circuited, and Y21 is the ratio of what? I2 by V1. So let us move to the options. What he is saying, that open circuited, no, that is not open circuited, that is short circuited. Short circuited forward current transfer ratio, short circuited reverse current transfer ratio, short circuited reverse voltage transfer ratio. So basically, if I am talking here, what is this? This is current of what? Output terminal, right? This is the current of output terminal and voltage of input terminal. So it will be the ratio of what? Short circuited forward current transfer ratio. That is called short circuited forward current transfer ratio. Means we are taking the current of the second terminal and we are taking in the ratio of the voltage of the first terminal. That's why we are saying this is the short circuited parameter of short circuited forward transfer ratio, current ratio. Okay, next. In a closed loop system, what is the primary purpose of integral controller? See, basically when we are using an integral controller, the main use of integral controller, your integral controller basically affect your steady state error. Right, it will reduce your steady state error. So if I am talking about what are the advantages or primary purpose of an integral controller, so it is to reduce the steady state error. Your integral controller will always affect your steady state behavior of the system. It will not affect the transient behavior of your system. So integral controller will affect your steady state behavior. Steady state behavior means steady state error, right? So it will minimize the steady state error. It will reduce the steady state error. Answer, what will be the answer? Answer will be C, right? Next one. Which factor does not significantly affect the line of sight communication? See, basically if I am talking about line of sight communication means you are standing here and your receiver, see, this is the transmitter, this is the receiver. So if there is a direct communication, line of sight communication in between these two, what are the factor? Atmospheric condition will also affect that condition. See, atmospheric conditions are there, how much humidity, how much that factor, that is also affect your communication, because EM wave, if your EM wave will travel through a water, atmospheric pressure and all of the things will affect your EM wave, propagation of EM wave. Antenna height is also a matter. If you can see that earth is not round, earth is not flat, it is a round shape, circular shape. If your antenna height is less, there is not possible. See, basically your transmitter is here, receiver is here. If antenna height is less in both the side, so is there line of sight communication is possible? No. line of sight communication will possible when you have a sufficient amount of antenna height. So antenna height will affect your line of sight communication. Signal frequency will also affect, because different frequencies which can penetrate through the medium, which cannot penetrate through the medium. That's why it is affect your communication. And modulation scheme, yeah, because modulation schemes are not affecting. Modulation scheme is means what? We are modulating a carrier signal by using a massive signal. So you can modulate anything that will not affect. EM wave will be affected by your atmosphere, antenna height, signal frequency. So these are the factor which is affected the line of sight communication, but the modulation scheme will not affect your line of sight communication, right? So that is the answer. Answer is D, because he is asking that which factor does not affect significantly your line of sight communication range, right? That is the main. Your modulation scheme will not affect that thing. Next one, yeah. A continuous time Fourier series of a periodic signal can be represented as. See, basically, I think there is two answers are possible, because we have two types of Fourier series you have studied. First type of Fourier series is what? Exponential Fourier series. In exponential Fourier series, we can write the Cn is equals to summation n is equals to minus infinite to infinite, right? Oh, sorry, not Cn, f of t, the signal f of t is equals to summation n equals to minus infinite to infinite Cn e raised to the power j n 2 pi by, this is continuous here, 2 pi by t into t. So basically f of t can be represented as exponential terms, as well as the second is trigonometric Fourier series. In trigonometric Fourier series, we have a naught plus summation n is equals to 0 to infinite an cos of n omega naught t plus bn sine of n omega naught t. See, basically there is an and bn. So basically we have two types of Fourier series. One is exponential Fourier series, another one is trigonometric. So both the answers are possible. You can fill any one of them, but it answer is, you can say A answer is also possible and B answer is also possible, right? So we have trigonometric Fourier series as well as exponential Fourier series, right? Next. Which of the following indicates the operation of BZT in saturation region? See, basically when your BZT is working in your saturation region, so this is our BZT, this is base, this is collector, this is emitter. See, in saturation region, both the junction, emitter, base to emitter junction, base to collector junction, this is collector to base junction, and base to emitter junction, right? Both the junctions are forward bias. Forward bias means both the junctions are on. So it will be work like a short circuit. So we can say there is a zero voltage in between these two terminals. Or in practical cases, in ideal case, that will be 0 volt between collector to emitter, but in practical case, the VCE should be less than or equals to 0.2 volt. First thing, your VCE should be less than or equals to 0.2 volt. So you can check either from any one of the answer, this answer is correct, because VCE is less than 0.2 volt, and because IB should be greater than 0, because both the junction, collector to emitter, collector to base, both the junctions are forward bias. So IB will be greater than 0, IC will be greater than 0, and VBE will be greater than 0.7 volt. So you have to understand one thing here, that when your transistor is in saturation mode, right? In saturation region, what happened to your transistor? Both the junction, collector to base junction, base to emitter junction, both the junctions should be forward bias, and collector to emitter junction should be short circuited or its voltage should be less than 0.2 volt, very small voltage across the collector to emitter voltage, right? Both the junctions are forward biased. This means IB should be greater than 0 and IC should be greater than 0. So that's why when your transistor will be in saturation region, answer will be C. Which of the following is a necessary condition for the Routh-Hurwitz stability, right? So if I am talking about the necessary conditions, there are two conditions, necessary conditions. I am talking about necessary condition. The first condition is if you have a characteristic equation, you have a CH equation, characteristic equation that is A naught s to the power n, A1 s to the power n minus 1 like that. Last is an is equals to 0. We have the characteristic equation in the form of this. So the coefficient, these coefficient of the characteristic equation should have same sign, right? So what will be the answer? All the coefficient of its characteristic polynomial should be positive. So this is the necessary condition. Positive, he is saying positive, either he can say negative, but sign should be same. Because if they are negative, we can take the negative out, all the coefficient became positive, we can put that on the left hand side, right? So basically, when you have a characteristic equation, the first condition, that is the necessary condition, if there is any sign will be negative, you can directly say that your system is unstable, right? The first condition, necessary condition, that the sign of all the coefficients should be same, either it is positive, either it is negative. So he is giving the answer that all the coefficient of its characteristic polynomial should be positive, right? The next condition, after seeing this, we will make the Routh table. In the Routh table, for a stable system, the sign change in the first column, there is no sign change in the first column, right? So for the stability of a system, so basically the necessary condition, that is necessary condition, not sufficient condition. Necessary condition is that all the signs of the coefficients should be positive, or you can say all the signs of the coefficient should be same, right? So answer is A. Okay, next one, which of the following is a hexadecimal equivalent of a octal number? See, whenever you have given with a octal number, you have to convert that one into hexadecimal. What you have to do? See, there is two ways to do this thing. First, this octal number converted into decimal. After decimal, we will convert back that into hexadecimal. There is another way, which I am going to discuss here, that we have a 7532. So basically what we can do, first we will write a binary number. So to write a binary number for an octal number, what we have to do, we have to write a 3-bit code for each digit. So 2 can be written as 0, 1, 0. 3 can be written as 0, 1, 1. 5 can be written as 1, 0, 1. 7 can be written as 1, 1, 1. After writing this, what we have to do, I am writing it here, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. So make a group of 4, right? Make a group of 4 to go for the hexadecimal number. First, what we have to do, you have a octal number, convert that octal number into binary. To convert that octal number into binary, you have to write the 3-bit binary number corresponding to each digit. Then you can make a group of 4 from the left hand side to convert back that number into hexadecimal. That will be A. Right? Because if you go for this equivalent, that is 10 can be written in hexadecimal as A. Next one is 0101. That will be represents the 5. And this is 111. 111 means 15. 15 means F. So what will be the answer? F5A. If you go from the decimal, that will be a long process. You have to convert it, then one, and then you have to go back, because it is the easiest way to convert a octal number to the hexadecimal number. So answer will be F5A. Answer will be D. So this is the complete process I already explained here. Okay. Compute the DFT of a sequence. This is the sequence is given to you. We have to calculate its DFT. See, basically what we can do, we can calculate the first one. We can calculate the first one because first one is the same, right, in these two options. So what we have to do, first we have to write the formula. Formula for the DFT is this one. X of k is equals to summation n is equals to 0 to n minus 1, x of n is raised to the power minus j 2 pi by capital N k into n, and k is varying from 0 to n minus 1, right. This is the formula for DFT, right. So we have to find the 4-point DFT. What we have to do, see, basically this is the 4-point DFT because this sequence has the 4 point, so we have to calculate the 4-point DFT. So capital N is 4. Right. So capital N is 4. So we have to calculate the value of xk. So k will be varying from 0 to n minus 1, means k is equals to 0 to 3. So we can calculate 0 because this is same. No need to calculate that one. This is different. This is different here. See, this is different here in these two cases. So we have to calculate that one, and the last one is the same. So basically what we have to do, x0 we have to calculate. So x0, when you calculate x0, just put 0 here. So it will be the sum of what? X0 is the sum of all the values of xn. So sum of all the values of xn is 1 plus 2j. So yeah, right, we will go to the first value. No need to calculate this second value, right? No need to calculate this second value. As we calculate the first value, two options are eliminated here. We will go with two options. Now, what we have to do, we have to calculate the third value. No need to calculate the second value. As you can see here, the questions will be framed like this. If you go for the third value, x of 2, in x of 2, generally what you have to do, you have to go this equation. In this equation, what is happening here, you have to understand one thing. When you replace n is equals to 0, x of 0, then when you replace n is equals to 1, e raised to the power minus j pi. Minus j pi means minus. So there will be alternate plus minus. X of 1, then it will be x of 2, then minus x of 3. So you can directly alternate the sign, right? No need to calculate all of this stuff. You have to calculate only x of 0. X of 0 is always in your DFT. X of 0 is always, remember the thing, always is the sum of these values, given values. So as I got the sum of these two values is 1 plus 2j, right? Now you can see in the options is always put, because in this exam you don't have the lot of time to solve the questions, right? We have a very less time and we have the 100 question to solve their technical part. I'm talking about technical part, not about the non-technical part. There is also non-technical part, right? So in technical parts you should go from the options, how you can tackle these type of questions, right? So first one is the sum of all the elements, then the second element, third element. Always remember, third element is the alternate sign like this in the 4-point DFT. So alternate means this multiply, first multiply with j plus, second multiply by minus 0, third multiply by plus, fourth multiply by minus. So it will be minus 1 plus 2j. Minus 1 plus 2j, this option is eliminated. So only B will be left. So you will go like this in this type of question. So no need to solve complete one. You have to check only some elements here, right? Okay, move to the next question. What is the characteristic impedance of a coaxial cable having inner conductance, radius of 1 mm, outer conductor, radius of 3 mm, dielectric constant? So this is the formula for the characteristic impedance of a coaxial cable. So you can directly plug in the value. So Z naught is going to be 60 divided by under root of epsilon r. Epsilon r is 9 ln d. D is the outermost cell dimension, that is 3. and divided by 1. When you put these values in the calculator, what we got here, that will be 60 divided by 3 ln of 3. 60 divided by 3 is 20. Ln of 3 1.732 like this. So when you calculate these values, and that will be around 1.09, that will be 21.97 exactly. It will go towards the 21.7, right? Next question. The response of a circuit immediately after the input is suddenly applied is called as, see, basically if I am talking about the response of a system, there are two types of response. I am taking generally an example. This is a response of a system, unit step response of a system. So basically it will consist of two parts, that is transient response up to 4 tau, 4 time constant. After that we have a steady state response. So basically as I apply the input at t equals to 0, immediately after applying the input, which type of response we are getting? That is transient response. So what will be the answer? That is transient response, right? Next, in a TDMA, what is the purpose of guard band between the time slot? Right? The main purpose of the guard band to provide a separation between the two adjacent channel, so that there will be no interference, right? And the another one is propagation delay difference. So that if there is a propagation delay difference, when one signal is going, another signal is going, so if there is a propagation delay, that will be compensated, right? So what will be the answer here? The improvement coding efficiency, no. Allowing the frequency hopping, no. To compensate the propagation delay difference, right? That will be the answer, right? Next, in the context of digital communication, what is the primary benefit of using match filter? Match filter is used to remove the intersymbolic interference, or it will use to maximize the SNR at the output, right? So what will be the answer here? To reduce the intersymbolic interference, right? Maximize the SNR is also the second use of your match filter. The Fourier transform of a rectangular pulse. See, basically if I have a rectangular pulse from -1/2 to 1/2, amplitude is 1, this is our rectangular pulse. If I am taking its Fourier transform, what will be the Fourier transform? You can generally use -1/2 to 1/2, value is 1, e raised to the power minus j omega t dt. You know the formula for the Fourier transform. F of omega of a signal f of t is what? Integration minus infinite to infinite f of t e raised to the power minus j omega t dt. So when you calculate it, it will be e raised to the power minus j omega t divided by minus of j omega. That will be the limit from -1/2 to 1/2, and we will plug in the values here. So minus will be combined above, that will be 2 upon omega sine of omega by 2. So we can write it as sine of omega by 2 divided by omega by 2. So basically it is a sampling function, sampling of omega by 2, right? That is the sampling function, or we can say the sinc function. Sinc function is defined as what? Sinc of x is equals to sine of pi x by pi x. So we can multiply this here, we can multiply by pi, we can divide by pi, so basically it is pi, and we can multiply by pi, divide by pi. So it is become pi sinc of pi will be covered, so omega by 2 pi. If you are going for the omega domain, if you are going for the f domain, omega is equal to 2 pi f will be cancel out, and this pi will be also calculated from the below one, so this pi will be eliminated, so it will be sink of F domain. It will be sink of F, right? So in F domain, that will be sink of F. So basically, if I'm talking about from the options, what will be the delta function? No. It will be exponential function? No. Unit step function? No. It is a sink function. So basically, the Fourier transform of a rectangular pulse will be a sink function, or it will be a sampling function. Whichever will be given, you can put that answer, right? Next. How many satellite signals are required to calculate a precise 3D positions using GPS? See, basically, if we are printing a 2D figure, right? 2D figure we can print with the help of 3 satellites. But for getting a 3D peak position of an object, we required at least 4 satellite, 1 satellite for time domain calculation. So what will be the answer? A is the answer. So there is, if you are going for the 2D figure, we require the 3 satellite. If you are going for the 3D positioning, you are requiring the 4 satellite. 1 satellite is required for the clock synchronization, right? Okay. In Nyquist plot and circle -1 J0 point, right? That is J0 or 0 point, J0 point, n times in an anti-clockwise direction, right, and has z zeros of an open loop system in the right half of S plane, then the number of poles of the closed loop system in the right half of S plane. So basically n is equals to what? P minus z. So from this one, P is equals to what? Z minus n. So what will be the answer? A will be the answer, right? Next. So most of the questions are theoretical. Some of the questions are numerical from this exam. So basically, after the gate, it will be very much helpful for you to go through these things, because in the gate exam we are not dealing with the most of the theoretical part, we are dealing with the numerical part, right? And in this exam, after the gate, I think you have 1 month. So how you can approach that exam? You have to read all of these theoretical things. So with the gate exam, you can do one thing: you can join YourPedia module. In the module, you can only up to the gate you can arrange only 2 to 3 hours to revise all of these things. So the Thevenin theorem is applicable to which of the following network? Thevenin theorem किसके लिए applicable होगी? The Thevenin theorem will be applicable for linear network. Correct. See, basically Thevenin theorem is applicable only for the linear network. He is not talking about the load. There are two things. One is network, another thing is load. See, basically in Thevenin equivalent we have two things. You have a network, and we have a load RL here, right? This is load. So basically, if I'm talking about this network, not about the load, so this network should be linear, right? Non-linear network, it is not applicable. Yeah, if he is asking about the load can be non-linear. It can be applicable for linear as well as non-linear loads. But if he is talking about the linear network, that it is only applicable for linear network. So answer will be C. Right. For an earth station transmitting a power of 25 dBW, right, this is dB and this is normal power, with a back-off loss of 3 dB and total branching and feeder loss of 3 dB, right. The transmitting antenna gain is 25. Determine the effective isotropic radiated power. Effective isotropic radiated power is always equals to what? Power input minus losses, I'm writing it in dB, and gain of the antenna. So basically power input is how much? 25. Losses, there are two losses. One is back off loss, another one is branching and feeder loss. So that will be 3 plus 3, and plus gain of the antenna, that will be 25. So answer will be 50 minus 6, that will be 44 volt. So answer will be D here if he is asking about the losses. Which of the following statement is true regarding the simplifying a Boolean function using K-map? See, if you are doing the minimization of Boolean function by using K-map, we generally make the group of ones, right, in the power of 2 raised to power n. So basically first we are trying to, let us take, we have a 4 variable function a, b, c and d, right? You have a 4 variable function. We generally make a 4 variable K-map like this. We generally make a 4 variable K-map like this, and we can put a, b, c, d, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is your 4 variable K-map. In 4 variable K-map, we can try to make a group like into 2 to the power. So first we are trying to make a group of 16. If 2 to the power 16 is not possible, then we will go for 2 to the power 3. 2 to the power 3 means 8. We are trying to make a group of 8. Then after doing this, if 2 to the power 8 is not possible, means 2 to the power 8 not, we are talking about 8 group is not possible, then we will move for the group of 4. If group of 4 is not possible, then we will go for the pairs. So basically we generally make a group of 2 to the power. So you can only group adjacent one in the power of 2. So what will be the answer? A. So basically we are making the group in the power of 2s. Okay, this is 8085. So basically if we are talking about the 8085 instruction, rest instruction, REC, restart instruction, there are 8 restarts. Rest 0, this is software defined you can say interrupts handling capacity. So there are rest 0, rest 1, rest 2, rest 3, rest 4, rest 5, rest 6, rest 7, and they are having their corresponding address. So if there is a rest 2 interrupt there, then it will be go to this address. So this is the address. So he is generally asking how many restart instructions are available in 8085 rest instruction. That will be 8 instruction. For each rest instruction there is a address specified. So at that address it will go, right, after he is receiving that interrupt. Next thing is, what is the effect of increasing a bypass capacitance value in a single stage BJT amplifier with emitter degenerate? So basically if we have a emitter bypass resistance, capacitance, so basically what is this? You can check it here. We have a RE resistance and we have a capacitance here. So this is a circuit. Let us take it is a Bernoulli circuit. So basically this RE resistance, if this RE resistance, we consider this RE resistance, it will provide the negative feedback. We are taking the input here, we are taking the output here, right? So this RE resistance is going to be introduced in your circuit as negative feedback. Negative feedback will decrease your gain. If I put this capacitance, this is called emitter capacitance, right? Bypass emitter capacitance. If I put this bypass emitter capacitance, it will neglect the effect of this RE resistance. Means it will be short circuited for AC. When it will be short circuited for AC, RE will be removed from the circuit. It means negative feedback will be removed from the circuit. As you know that negative feedback will decrease your gain. So basically as your negative feedback removed, so your voltage gain will be increased. That is the question. This is the good question. So most of the questions are good, but they are theoretical questions, so right. Next is, what is the execution time of NOP instruction in 8085 microprocessor with a 3 megahertz clock? So basically if the clock frequency we are getting, that is 3 megahertz. So we can calculate the T clock period, that will be 1 divided by 3 into 10 raised to power 6. So it will become 3.33 into 10 raised to power minus 7 second. That is the clock period. So basically when you are executing NOP instruction required 4 machine clocks, right? 4 clocks. So it means 4 times T clock will be your execution time. So 4 times T clock, when you did that, that will be 1.33, right? 10 raised to power minus 6. So therefore the execution time of the NOP instruction is 1.33 microsecond. In context to the channel capacity theorem, what role of a channel bandwidth play in determining the capacity of the communication? Increasing the channel bandwidth by decreasing the channel capacity. Okay, you can see here the channel capacity C is equals to B log of 2 base 1 plus SNR. So basically increase the channel bandwidth, decrease the channel capacity? No, because channel capacity is directly proportional to the bandwidth. The channel bandwidth is directly proportional to the channel capacity. That will be the answer. So it is a directly formula based question here. Next. For a underdamped second order system, zeta will be C. If I am talking about, there are 3 types of system. One is, 4 times. Zeta equals to 0, zeta equals to 0 means undamped. When your zeta from 0 to 1, this is underdamped. Zeta equals to 1, that is critically damped. Or last, zeta greater than 1, that is overdamped. So basically we have 4 types of system. He is asking for the underdamped system. Underdamped means zeta from 0 to 1. So what will be the answer? Between 0 to 1. The bandwidth of an RLC parallel circuit. See, basically if you are talking about the bandwidth is equals to what? F naught. F naught means resonance frequency divided by quality factor. This is the relationship between the bandwidth, frequency of oscillation, or you can say resonance frequency, and quality factor. So inversely proportional to the quality factor. So bandwidth is always inversely proportional to the quality factor. Closed loop control system are characterized by which of the followings? Direct control of the system output without the sensor. That is not correct. Because if we are talking about a closed loop system, in closed loop system what will we have? This is the GS, this is the HS. See, this is your plant controller. In this GS we have plant controller and all of the things, and we are taking the feedback from the output. So inside this feedback there are sensors, transducers are there. So basically direct control of the system output without the sensor, that is not correct. Use of feedback to reduce the system error, that is the main thing. Because in this one, the closed loop control system, we generally monitor the output and we are trying to find the error, and the controller will try to minimize that error. So what is the use? Use of feedback to reduce the system error independent from the external environmental change, that is also not correct. And external environmental change will also affect that one. It is not independent from that one. So answer will be B. Which of the following is the correct binary representation of a hexadecimal number 3A9? So this is a hexadecimal number. I already taught you in the octal question that if you have a hexadecimal number, how you can convert that hexadecimal number into binary? Just write a 4-bit binary code corresponding to each digit. So 9 can be represented as what? 1001. Next, A can be represented. A means 10. 10 can be represented 1010. 3 can be represented as 0010. 11. So that will be the answer. So that is the answer is A. So directly you can write a 4-bit code for each digit, right? Right. Next question is, in a phase modulation, what happened to the phase of a carrier wave when the amplitude of the modulated signal is 0? See, basically, if I am talking about the phase of a carrier signal when it is a phase modulated signal, that will be phi I is equals to phi C Kp into mt. So basically, if your message signal is 0, then the phase of carrier signal is equals to what? Constant, and equals to phi C. So remain constant, because this phase will only change when you have a message signal. So message signal, when message signal will change, its value will change from this phi C. So right, if your carrier signal have a constant phase phi C, then your phase modulated signal will also have a constant phase from this equation. Next, which biasing method provide you the best thermal stability for a bipolar junction transistor? See, if I am talking about the thermal stability, there are self bias, voltage divider bias, there are several type of biasing there. If I am talking about the best one is voltage divider bias, which is providing you the best thermal stability factor S is almost equals to 1 for that one. So that the answer is A, that is voltage divider bias, right? In a clipper circuit using a diode, what component is typically used in the parallel with the diode to control the clipping threshold? That will be a voltage source. Always there is a voltage source in parallel with the diode to control the controlling action in a clipping circuit, right? Clipper circuit, you can say. Which of the following statement is not true about the commutative law of the Boolean algebra? See, basically, if I am talking about the commutative law for AND, that is A and B is equals to B and A. For OR, A or B is equals to B or A, right? So if we talk about the three, this is the commutative law, this is the associative law, not the commutative law. So basically it is true, it is commutative law, it is also commutative law. So basically what? This is associative law, not a commutative law, right? So that will be the answer. Which of the following is a characteristics of a sinusoidal oscillator operating at its frequency of oscillation? So basically when your sinusoidal oscillator operates its frequency of oscillation, the phase shift around the loop is not maximum, phase shift around the loop is 360 degree or 0 degree, right? Amplitude of the output signal should be constant. That is the main thing. So basically when you operate that sinusoidal operator at a constant frequency, then its amplitude will become constant. That will be the answer. Frequency of the output signal will vary with the time. See, in the oscillator, your frequency, if it is operated at its oscillation frequency, that will remain constant, and loop gain is always become 1 when it is working, right? And generally in practical cases, we are taking the loop gain around smaller greater than the 1, right? So what will be the answer? The amplitude will be constant. For a maximum power transfer in AC circuit, the load impedance, see, for maximum power transfer, the load impedance ZL should be the complex conjugate of your Thevenin resistance, right? So complex conjugate of your source impedance. You already know that thing. This is the basic question, right? Next one is, in PCM, what effect does an increase in number of quantization levels? See, increase the bandwidth, decrease the bandwidth of the signal, increase the quantization noise, decrease the quantization noise. See, basically if I am talking about the quantization noise is delta square by 12. So when you, this is Qn, quantization noise, QE, you can write quantization error or quantization noise, delta square by 12, not that's delta square by 12. So basically, if you increase the level L, step size delta is equals to what? V maximum divided by your, you can say V peak to peak, not maximum, that is peak to peak. Delta is equals to V peak to peak divided by the step size L. When you increase the step size, your delta will decrease. When your delta will decrease, your quantization error will decrease. So quantization noise will be decreasing. In a Bode plot, what is the significance of gain crossover frequency? See, if I am talking about the gain crossover frequency, the gain crossover frequency is calculated where your gain is 1, right? Gain crossover frequency means when your mode of Gj omega, Hj omega should be equals to 1, that frequency is called as omega Gc. The frequency at which your gain is 1, that frequency is called as omega Gc. So indicate the unity gain frequency. Yeah, that's true. It indicates the unity gain frequency. If I am talking about the phase crossover frequency, the phase crossover frequency is the frequency at which the phase of your system is equals to minus 180 degree. So that frequency is called as omega Pc. So there are two frequencies, one is gain crossover frequency, another one is phase crossover frequency. Gain crossover frequency is the frequency at which your gain is 1, and phase crossover frequency is at which your phase of the system is minus 180 degree. The system is said to be distortionless if its group delay is constant. See, basically when your system is distortionless means its amplitude means the systems, if you have a system like this, h of let us take h of t. If you take its Fourier transform, that will be h of omega e raised to the power j angle of h of omega. So basically this amplitude should be independent of frequency, this magnitude should be independent of frequency, this phase should be a linear function of frequency. So if your magnitude is independent of frequency, phase is a linear frequency function of frequency, then we can say that your system is distortionless. See, if I am talking about the group delay will be what? Angle of h of j omega upon omega, you can say d terms are there. So basically, if this is a linear function of frequency, this is also frequency, so that will be cancel out, minus is also there. So omega will cancel out, so we will go the constant value. So basically, the group delay will be constant. Phase delay will also be constant for this one, right? The Hamming code 74 code, how many bits are used for message, how many bits are used for the error correction? See, basically in 74, this last digit represents the message bit. So there are 4 message bit, and this is message plus error correcting bit. Message plus error correcting bit. So message bit are 4, error correcting bits are 7 minus 4, that is 3. So answer will be A. Always remember about the Hamming code. A S-stable multivibrator using IC 55555, if the value of R1 and R2 and C are given to you, then what is the time period? See, basically if you have a S-stable multivibrator, the time period of S-stable multivibrator is 0.693 R1 plus twice of R2 times C. So you can plug in the values, you will got the value as 1.71 seconds. So these are the formula based question. No need to explain here rest of the things. So these are the basic things about this. The characteristic equation of a system is given to you. Find the range of values of K for the system would be stable. So this question will be done by Routh-Hurwitz criteria. So we can make a table S cube, that will be 1 and 7, then we have S square will be 3 and K, then we have to find the coefficient of S1, you have to multiply this one here, you have to multiply this one here, so 21 minus K divide by 3, this divide by this, and this is 0 because there is nothing left here. So when you find this one, so if you have this 0, you can directly put that value here. So we will go to this one. This is our route table from this one. So from this route table, if your system will be stable, there will be no sign change in the first column. So it means K should be greater than 0 from here, because this is positive, this is positive, it should be positive, it should be positive. So K will be greater than 0 from here, and 21 minus K divided by 3 should be greater than 0. So K will be less than 21. So we will got two values of K greater than 0, K less than 21. So K, the final value K should be greater than 0, less than 21. So K should be greater than 0, less than 21. Answer will be B. See how many 4 to 1 multiplexer will be needed to implement the 30 to 1 multiplexer. See, basically if I am talking about, this is the figure how you can implement a 32 to 1 multiplexer using 4 cross 1. So we required 1, 2, 3, 4, 5, 6, 7, 8 here, 2 here, and 1, 2 to 1 multiplexer. So we required 10, 11 multiplexer. I don't know how he give the answer as A. This is impossible. Should be answer is D. So we required how many? That will be 11, right? Not 8. That is impossible to design with 8. Either he say that you can use the external gate, then it will be possible, but I don't think with the 4 cross 1 marks it is impossible to design with 8. It's required to at least 11. What is the crucial factor to be considered when designing active high frequency application, active filters for high frequency application? See, basically when you are designing a you can say active filters we generally use op-amp, right? In op-amp, what is the most important thing? Generally we can use a op-amp anywhere, but there is a term that is called slew rate. Slew rate is how much change how fast your input change and output will be reflected that change, how fastly. So if your system will not cope up with this slew rate, then there will be error, right? So if you think that your input is changing very fast and output is not cope up with this change, right? It will not change according to this change of the input, so there will be a error, right? So that is the main thing. The slew rate of the operational amplifier should be considered because it will change in the output with respect to change in the input. If your input is changing fast and output will changing slow, right, it means it is not meeting your slew rate configuration, and you cannot design a proper active filter at a high frequency application. So slew rate is most important thing here for the designing of a filter. Pointing vector represents, see, basically in the EM wave, the pointing vector will be representing what? Pointing vector will represent the energy flow, or you can say the rate of energy transfer per unit area. See, average pointing vector, what is the unit? Watt per meter square. That is the unit of average pointing vector. What means? The energy or power flow per unit area. That is the answer is A, and it is given by P is equals to E cross H. Which of the following latch will be change its output only when the enable signal is active and there is a change in the input? See, basically if you talk about the D latch is the one of the latch which is having, when enable is 1, then when your when your input is 1, output will be 1, input will be 0, output will be 0. So the D latch will change the same thing, right? Not gated, that is D latch. Oh, sorry, gated D latch, not D latch, that is gated D latch, because enable in D latch, if you have only normal D latch, there will be no enable. If we have a gated D latch, it means there is an enable signal we introduce with the gated terminal, right? So gated latch is called as transparent D latch, or you can say transparent D latch, that will be work as a When you have an enable signal 1, then your output will be same change as your input will change. In a sinusoidal oscillator, what is the phase shift around the loop at a frequency of the oscillation? As I already told you in the starting, that if you have an oscillator and it is working at a frequency of oscillation, there should be gain around the loop should be equals to 1 or little bit higher than the 1, right? And the phase change around the loop, there will be 360 degree. That is the Bragg-Husson criteria. So if it is working at the frequency of oscillation, then it will be 360 degree around the loop, right? Which parameter of a MOSFET is crucial in determining the unity gain bandwidth? See, basically what is the formula for unity gain bandwidth? Ft is equals to Gm over 2 pi multiplied by CGS into CGD. These are the CGS is what? Gate source capacitance. CDS is what? Gate to drain capacitance, right? So basically Ft is directly depend on what? Gm. Gm is called what? Gm is transconductance. So capacitance per unit area, it will not depend on this. This will threshold of voltage, not depend, it is depend on the transconductance. Channel length modulation, it is not depending, it is depending on the Gm, that is called as transconductance, right? Electric flux through a closed surface in a free space is equals to, see basically if we go through the Gauss law, the Gauss law says that the electric flux E dot ds is always equals to Q enclosed divided by epsilon naught. So that is the electric flux. The electric flux strength times the area नहीं, क्या होगा? Charge enclosed divided by the epsilon naught. That will be the answer. So this is the question from the Gauss law, right? Next, diffusion current in a semiconductor arise. See, basically there are two types of current in your semiconductor. One is drift current, another one is diffusion current. Drift current will be arise due to applied electric field. When you apply a electric field across a semiconductor, then there will be the current that is called as drift current. And diffusion current, if I am talking about diffusion current is arise due to concentration gradient. If you have a higher concentration at one place and lower concentration with another place, let us take an example of liquid. It will work like liquid. If you have a higher level at one side, lower level at one side, what will be the liquid do? Liquid will flow out from the higher to the lower side. The same thing will happen here. Inside the semiconductor, if you have a higher concentration on one side, you have a lower concentration on another side. So what happens? The concentration will or electron or holes will go to maintain a constant level, and they will flow from higher concentration to the lower concentration. Whenever your electron or hole will flow from one position to the another position, they will contribute a current that is called as diffusion current, right? That is called as diffusion current. Next one is impedance of RLC circuit at resonance. If we have R, L and C, this is R, this is XL, this is XC. So minus JXC, this is JXL. So total impedance Z is what? R plus JXL minus XC. See, basically at resonance, XL should be equals to XC. Whenever your XL equals to XC, so this term becomes 0 at resonance. So we have only resistance. So at this one, at resonance, we have purely resistive. So what will be the answer? Purely resistive. So the impedance of RLC circuit at resonance will be purely resistive. Bragg-Husson criteria. See, what you are seeing here, there are three questions on the same concept. Oscillator, oscillator, oscillator. In the starting, he will ask, second question, the phase shift around the loop. Third is Bragg-Husson. So he directly asks the question that what is the Bragg-Husson criteria? The loop gain must be 0. No. Loop gain should be 1. That is the Bragg-Husson criteria I already discussed with you. The phase shift around the loop is 180 degree. No. The phase shift around the loop should be 360 degree. The product of loop gain and feedback factor must be 1. I already told you that thing. The loop gain means around the loop the gain should be 1. The product of loop gain and feedback factor must be greater than 1, not greater than 1. It should be equals to 1, but little bit greater than 1 because of the losses. So that we will go to a sustained oscillation. So the correct answer, if he is asking bracket, so that will be must be equals to 1. When you have a delta connected network and you have to convert that into the Y connected network, so what will be the formula from delta to Y? So that will be the formulas from delta to Y. You already remember that thing. So in this one we have the product above and divide by the addition. So what will be the addition? We have the resistance is equals to the product of two delta resistance connected in a common terminal and divided by the sum of these resistance. So answer will be A. So you can check it from this formula. In the twin tube CMOS process, the P-wall is used primarily for the, see, basically when we are going to P-walls are primarily used to form the fabrication of NMOS. When we have P-walls, that will be used in formation of the NMOS, and N-walls are used to formation of the PMOS. So what will be the answer? Fabricating the NMOS transistors, right, in the CMOS technology. Convolution is of an input signal with the impulse response of a LTI. See, basically if you have a LTI system, this is your LTI system, we have a input XT and you have impulse response ST. So basically the output YT is always equals to the XT convolution with HT. So output of the LTI system is always equals to the convolution of input and the impulse response. So what will be the answer? The convolution of input signal and the impulse response of the system will be the output of the system. So what will be the output or the response? The output of the system for the input. The answer will be D. How does white noise affect the performance of a communication system? See, it is improve the signal to noise ratio because it is a noise. Noise never improve the signal to noise ratio, it will degrade the signal to noise ratio, so that will be not the answer. It has no effect on signal quantity, that is not the answer. See, basically when you have a noise, let us take you have a sending a 5-volt signal like this, so noise will be degrade its amplitude, it will change its amplitude by in a random manner, so it will affect the signal quantity, correct, it degrade the signal quantity, that is the main thing, because it will introduce the noise inside the signal, it will degrade the signal quantity, it enhance channel bandwidth. The noise will not affect your channel bandwidth, it will only affect your signal quality, right? So what will be the answer? C. Calculate the reflection coefficient of a VSWR. So VSWR is what? 1 plus reflection coefficient divided by 1 minus mode of reflection coefficient, and from this one we will go that the reflection coefficient is VSWR minus 1 divided by VSWR plus 1. So from this one we will go the reflection coefficient, that is 2 by 3. That is the easy way. Next. Most of the questions are the formula based questions are here. The next is in a BZT configured as a common emitter amplifier, what is the role does the emitter resistors play in biasing? See, basically I already told you that when you have a emitter resistance here, in one of the question I already told you, this is, we are taking the output here, we have input here, this is your RE resistance. So this RE resistance will provide you the negative feedback. It is used as a feedback element between the output and the input. So basically it will provide the negative feedback from the output. So what is the use? It will provide the negative feedback to stabilize the biasing point. Why we are using this RE resistance? When you see that the stability factor, to solve the stability factor without the RE, with RE, you can see that with RE the stability factor is tends to 1. Without RE is go away from the 1. So it will improve the stability of the system. So basically it will provide the negative feedback to stabilize the biasing point. Right. You have broadside array operating at 50 centimeter wavelength, consists of 4 half wave dipoles spaced 25 apart, each element carrying a radio frequency current in the same phase of a magnitude of this one, what will be the radiated power if the radiation resistance? See, basically first we have to calculate the radiated power of a single element. For a single element radiated power, this is the single element radiated power, that will be 1 by 2 current I ka square multiply by the radiation resistance. That will be the formula. If you calculate it, that will be 2.52 volt. And if you have an array of this antenna, one antenna radiated that much amount of power, second that much amount of power, third, fourth, so we can calculate the total radiated power. Total radiated power is 4 times the radiated power of the first antenna. That will be 10.08. So what will be the answer? That will be the B. So if we come out with this type of question, you can directly solve these questions like this, because it is given to you that it is having the same phase and a current of 0.2. So one antenna having current this much and radiation resistance of one antenna is 126. So we can directly calculate the radiated power of one antenna and we can calculate the radiated power group of antennas. Find the gain of the system with the transfer function this for a DC frequency, 0 frequency. So basically, as you know, we can replace S is equals to J omega inside this. So it is become J omega, J omega, J omega, J omega, and you can put omega equals to 0. So it is become 2 divided by 1 into 3 into 4. That is 1 divided by 6. So that will be the answer is T. When he is asking the 0 frequency gain, that will be the when you replace the omega equals to 0. So that is 0 frequency. So 0 frequency gain is 1 by 6. In a 4-bit binary adder, if the input A is 1101 and B is 1011 with internal carry 0, what will be the sum and final carry? See, basically when we add A plus B, so it is 1101, 1011. So when you add 1 that is become 0, 1 carry here, right? And 1 again 10, 1 carry here, 1 again 10, 1 carry here, 1 10, then 1 plus 1, that is 1 is here, carry 1 is here. So basically this is the sum and this will be the final carry. So there will be sum is 100 and final carry is 1. So what will be the answer? That is T. 100 and carry is 1. The electric field measured in a far field region of an antenna. Far field, see basically whenever your antenna will work in a far field region, the electric field of the antenna is inversely proportional to the distance, right? Inversely proportional to the distance. In near field region there is a R square term, R cube terms, but in the far field region we can neglect the R square term, but in near field region there is a R square terms also there. So if he is giving you that in a far field region, so electric field is inversely proportional to the distance. So we can say that E1 upon E2 is equals to R2 by R1. So you can put the values and E1, E2, you can calculate the value of E2. E2 is going to be at the second distance, it is going to be how much? I already calculated this here, you can check it. So that will be 1 by 10. And what is the average power density? That will be E2 ka square, because we are taking that electric field is given in the RMS form. E2 square divided by neta, and you can plug in the value 1 by 100 into 1 upon neta is 125 for free space. When you calculate it, that will be 26.6 microwatt per meter square. So remember this thing, when it is given to you, you can directly calculate that in the far field region electric field is inversely proportional to the distance, and the average power density, whenever he is asking for the average power density, see basically there are two types. If it is maximum value of electric field is given to you, you can use this formula 1 by 2 E naught square, that is E naught mod square divided by neta. If RMS value of the electric field is given to you, then P average is going to be ERMS square divided by neta. So that is the main difference between these two things, right? So answer will be 26.6. 26.6. B answer will be there. In a semiconductor fabrication, the process used to pattern specific area of a wafer for a subsequent removal or deposition of the material is called as lithography. So see, basically there are several processes. Annealing lithography. Lithography is the process to removing several area or introducing any area. So the answer will be lithography. When we study the fabrication of the semiconductor materials, then we will see that what is lithography, annealing, epitaxy, diffusion, these are the things there. A portable device required low power consumption for extended battery life. Which logic family would be most energy efficient choosing for the digital circuitry? See, basically, if we are talking about portable low power consumption is CMOS. See, if I'm talking about the CMOS graph, you can see there is this type of input output characteristic where we have the CMOS. The CMOS will take only power during this transition. When it go from low to high or high to low, only the transition time it will take the consume the power. After that, there is no current will flow through the CMOS circuit and no power consumption will be there, right? So the one thing about the CMOS consumption, it will take the lesser power and the power will only be consumed during this transition from 1 to 0 or 0 to 1. Whenever it goes to 1 or 0, there is no power consumption, so it will take very less power. So what will be the answer? That it will be CMOS in the logic family. It will take very less power. What is the main purpose of intermediate frequency stage in a super heterodyne receiver? See, basically, if I'm talking about the super heterodyne receiver, after the you have an antenna, receiving antenna. You have a receiving antenna, you receive a RF signal. When you directly feed that signal to your you can say your filter or receiver, right? Like let us take, you have transmitting a DSP signal and you are using a synchronous detector there. If you feed that directly to the synchronous detector, there is several things which we come into the picture. The one thing is the bandwidth of your filter and lots of the things. So what we can do, we can use a super heterodyne receiver. Inside the super heterodyne receiver, we have a intermediate frequency stage. What is the use of this intermediate frequency state? To take your all the signal onto the same frequency so that your filtering will be easy. So what will be this? To facilitate easier and more selective filtering, right? So that we have a very selective filtering. So that is the use of this one. What is the main cause of GPS signal degradation in urban environments? See, basically, if I'm talking about the urban environment, satellite geometry is not the factor. Another one is tropospheric effect, that will be always available. Either it is an urban area or non-urban area. Isotropic effect is also available. Either it is urban or non-urban area. Satellite geometry is also available. Either it is urban or non-urban. There is a multipath propagation. That is the important thing. See, basically in urban area there are several objects, so that there will be multipath propagation mostly available in the urban area. Non-urban area we can't get that multipath propagation that much amount that will be caught in the urban areas. The Hamming code, if one of the received bit is incorrect, which of the following is true? See, whenever your one bit is incorrect, then you have a syndrome. Syndrome will be point out the position of the error bit. When we studied the Hamming code, what we can see inside the Hamming code, we have a syndrome. Syndrome vector will represent that which bit position are in error. So it will tell you that which bit position in error, that is syndrome vector. Will point out the position where the error will be occur inside the group of bits. Right. Next one is, what is the relationship between the modulation index M and the amplitude C? Basically, if you talk about the AM signal, the modulation index M is AM upon AC. Always remember this. The modulation index is AM upon AC. So what will be the answer? B will be the answer. How does the positive clipper circuit operate when diode is forward bias? See, positive clipper means it will clip out the positive part of your input waveform. See, basically we have an input waveform like this. If we have a positive clipper, the output will be the positive clipper. Output will be 0 from positive cycle, right? So output will be 0 for positive cycle. It will pass only the negative cycle. So basically positive clipper will clip out the positive cycle. So what will be the answer? Allow all the positive part of the input waveform? No, it block all the positive part of the input waveform. That will be the answer. It allow the negative as well as the positive part? No, it block all the negative part. That is no. So answer will be A. So that is the input of the positive clipper, that is the output of the positive clipper. Right. N-channel enhancement MOSFET, whenever your gate to source voltage is less than threshold voltage, your MOSFET, enhancement type MOSFET, will be in cutoff region. So to own that, to make a channel there, VGS should be greater than VT. If your VGS less than VT, then your MOSFET will be work in a cutoff region. Cutoff region. When your VGS is greater than VT, we have two types of region. Triode region, another one is saturation region. For triode region, VDS should be less than VGS minus VT, and for saturation region, VDS should be greater than VGS minus VT. So basically, whenever your VGS is less than VTS, then your transistor will be work in a cutoff region and there will be no current flow. Cutoff region means open circuited. Your MOSFET will behave as an open circuit. There will be no current flow between the cutoff mode. There will be no current flow between the drain and source. Single stage MOSFET amplifier, what is the role of Miller capacitance? See, basically at low frequency, if I draw the frequency response of your amplifier, this is the frequency response of our amplifier. At low frequency, at these low frequencies, the coupling capacitance will decrease the gain. At high frequencies, these Miller capacitance, or you can say the parasitic capacitance, will affect more, right? So at high frequencies, your gain will be decreased by parasitic capacitance. At low frequencies, your gain will be decreased by coupling capacitance. And at the mid band, we can say have a constant gain. So basically, he is asking at high frequency, Miller capacitance, what they do? Decrease the high frequency gain, increase the high frequency gain, stabilize the DC operating point, enhance the linearity. See, basically that will decrease the high frequency gain. So what will be the answer? High frequency gain, they will decrease. At high frequency, they will decrease the gain. Okay. In a BJT, base emitter junction is and collector base junction is biased in active region. See, whenever your transistor will work in active region, base to emitter junction will be forward bias and collector to base junction will be reverse bias. Remember that thing. There are four reasons of operation of the transistor. One is cutoff. Cutoff means emitter base junction, collector base junction. Both the junction are reverse bias. Saturation. In saturation, both the junction are forward bias. Both the junctions are forward bias. In active region, this is forward bias, this is reverse bias. In reverse active region, reverse active, this is reverse bias, this is forward bias. So that is the four reason of operation of your transistor. So he is asking for the active mode. So active mode means emitter base junction is forward bias and collector base junction is reverse bias. In context of LED, what does the quantum efficiency? See, basically when we talk about the LED, the quantum efficiency means how many number of photon it will emit, right? This is about the LED. LED means emitting the light, right? Emitted in the free space whenever the number of electrons injected into that, right? That is the ratio. It is the ratio of number of photon emitted into the free space to the number of electron injected into the LED. So what will be the answer? It is the ratio of number of photon emitted into the free space per second to the number of electrons injected into the LED per second. You have a number that is a binary number, you have to convert into gray code. So what we can do? We have 1 0 1 1. So whenever you have to convert into gray code, just write the MSB as it is. Then you have to XOR the previous bit with the next bit. You will go to the next bit, that 1 0, that will be 1. Right? XOR of 1 0, that will be 1. 1 0 XOR, that will be 1. 1 1 XOR, that will be 0. So what will be the answer? 1 1 0, that will be A. Right? In a shift register, if the binary number 1101 is initially stored in the register, it made of shift of 2 times in the right, which of the following should be the content of the register? See, basically initially there is, let us take 4 bits, that is 1101. Now the first time you rotate this into the initially the shift 2 times to the right, to the right. So it is become to the right. When you are shifting to the right, the 1 1 and 0 is here, 0 will be entered here. When you enter the second time, that will be shifted all the content towards the right. So 0 0, then this 1 1, this everything will be shifted here in the next, right? So that will be the 0 0 1 1. Answer will be C. So whenever he is asking for the shifting, shift it towards the right, towards the left. That is the main thing here. Which of the following statement is true regarding the bandwidth of an amplifier amplitude modulated signal? So whenever we are going towards the bandwidth of amplitude modulated signal, AM signal, either it is full AM, conventional AM, or it is DSB, both have the same bandwidth. The bandwidth is twice of the message signal bandwidth. Message signal bandwidth, right? Whenever you have to calculate the bandwidth of AM and DSB signal, the bandwidth should be twice of the message signal bandwidth, right? If he is asking for DSB having lesser bandwidth, half of this one. So what will be the answer? The bandwidth is twice of the highest frequency of the message. That is the B answer, right? You can check it. Here is the calculation, right? In the monostable multivibrator, I using IC the purpose of external trigger. See, basically, whenever you have a monostable without the external triggering, right? Without the external triggering, it will not work. We just provide the input, a small spark to the input, right? So that the process will start. So it will control the duty? No. It will just starting the process. Rest of the output will low state? No. It will initiate the timing interval. It will initiate. So answer will be C, right? So inside the monostable vibrator, without any external triggering, it will not work. It is required external triggering to initiate the complete process, right? So that is called, to initiate the timing interval, we required a external triggering in the monostable multivibrator, right? Next one is, during the process of interpolation, upsampling is followed by, see, whenever you have interpolation, the upsampling will always be followed by a low pass filter, that is called anti-aliasing filter. That is a low pass filter which is in terms of anti-aliasing filter. Every time interpolation is upsampling, then we have a anti-aliasing filter, that is a low pass filter. Okay. Next is, for a source with M equiprobable symbols, What is the formula for calculating the entropy? We have to calculate the entropy H. Entropy means what? Entropy, the formula for the entropy is minus summation Pi log of 2 base Pi. That is the formula for the entropy. See, if you have a source of m equiprobable symbols, we have m symbols, each are equiprobable, the probability of each symbol is 1 by m. So we can replace the Pi is equals to 1 by m and I is equals to 0 to m minus 1. So we can write it 1 over m log of 2 base 1 over m, right? Minus is there, it is written m times. So we will add them, so we will got that log of minus log of 2 base m. So we will take 1 over m. So we will take this minus inside, so it is become log of 2 base m. So that will be the entropy. The answer will be B. Whenever you have to calculate the entropy, that is the formula for the entropy. If you can remember that term, if you have a equiprobable symbols, the entropy of equiprobable symbols is log 2 base m, right? So m will be any numbers. Let us take, you have 3 equiprobable symbols. What is the entropy? That is log 2 base 3. That is the formula. In a rectangular waveguide, see basically in TE10 mode, see basically when you have a TE10, see this first term, if we have a TEMN, Mn means what? M is the number of half-wave variation along the broader dimension, and N is the number of half-wave variations along the narrow dimension. So there is TE10 means one half wave. So one variation in the broader dimension, none divariation in the narrow dimension. Again I am repeating, TEMN, M means number of half wave variation along the broader dimension, N is the number of half wave variation along the narrow dimension. So basically you can say the one variation in the broader dimension and none variation in the narrow dimensions, right? When the modulation index of an FM signal is much smaller, less than 1, the bandwidth of the FM signal can be approximated by which of the following? See, basically whenever you have a narrow band FM is always equivalent to the AM. Remember that thing. The narrow band FM is equivalent to the AM. So we can study the narrow band FM as a AM signal. That's why the narrow band FM does not have any practical importance, right? Because instead of generating a narrow band FM, we can directly generate an AM signal. That's why if he is asking for the bandwidth of a narrow band FM, you can directly say that the narrow band FM bandwidth is almost equal to the bandwidth of a AM signal, and AM signal is bandwidth is twice the highest frequency of the modulating signal. So remember one thing, whenever you have a narrow band FM, it is equivalent to the AM signal, and bandwidth of a narrow band FM is equals to the bandwidth of AM signal, and AM signal bandwidth is twice of the bandwidth of the message or modulating signal. Non-inverting amplifier using an operational amplifier. Okay, the voltage gain is determined by which of the following? See, you have a non-inverting amplifier. We are giving the input here Vi. This is the figure, right? We have to calculate the output. See, basically non-inverting amplifier, the gain V out is equals to what? Vi times 1 plus Rf upon R. This is the formula. What he is saying, that the open loop gain of the operational amplifier, the product of the input and the feedback resistor, no, this is the ratio of the feedback resistor to the input resistor. So that will be the answer. See, it will be determined. He is not saying that it's exactly equal to, it will be determined. It will be determined that the gain will be determined by RF upon RI. Which of the following condition is responsible for occurrence of aliasing? See, basically, if we are talking about the sampling theorem states that your sampling frequency should be greater than or equals to twice of the maximum frequency present in your message signal. Right? If this condition is satisfied, then there will be no aliasing. If this condition is not satisfying, means your sampling frequency is less than twice of the maximum frequency present in your signal, then there will be aliasing. Aliasing means there will be overlapping of the spectrum, right? So it will be the frequency if the sampling frequency is too low, right? That will be the answer. Fan out of a TTL gate is mainly determined by this. What is fan out? First thing you have to remember that. See, basically you have a gate. Let us understand TTL gate. I'm just taking. We have a TTL gate like this, and I am connecting several AND gate at its output on the same output, right? Several AND gates. So how many AND gates you can connect its output? That is called as fan out, right? See, basically let us take, it is providing a 5 ampere current and it is required 1 ampere current. So how many we can connect here? That will be represented, that is because one AND gate required 1 ampere current as the input, right? So because we have how many? We can connect the 5 AND gate at the output. So we can say its fan out is 5. So basically the fan out of a gate can be represented by what? The input current. It will depend on the input current, and input current will be depend on the input resistance. As much as you have the input resistance, it will require the less current. As it requires less current, large number of similar gate you can connect at the output. So what will be the that will be represented, that will be determined by the input resistance. Output resistance, no. Fan out will not depend the output resistance. Output resistance means fan out means how many the similar gates you can connect at the output of a gate, right? So basically it will depend on the input resistance of that gate, not on the output resistance. Capacitance will not, and power supply will not affect that. The line of sight of communication, the Fresnel zone is an important for determining see, basically Fresnel zone means there is no obstacle between the line of sight of communication. If there is an obstacle, then it will be not a Fresnel zone. So we can say it is ensured that signal path is free from the obstacle. Determine the height? No. It will determine that there is no obstacle between the line of sight of communication inside the path, right? At the boundary between two dielectric material, which of the following is continuous? See, basically if I am talking about the boundary between two dielectrics, first thing, the magnetic field. See, you remember that ST1 minus ST2 depend on what K? So it is not continuous. Normal component of electric, yeah. Basically dN1 is equals to what? dN2 on the dielectric medium. Current density and electric field, tangential component of electric field, not the complete electric field. ET1 is equals to ET2, but the complete electric field will not be same on the both sides. Only the normal component, you remember na, what are the boundary conditions are there? See, H is equals to what? ST1 plus ST2, HN1. And as similarly, this is H1, this is H2, H2 is ST2 plus HN2. So basically H1 or H2, both are not same throughout the boundary. They will change, right, inside through the boundary of the dielectric. Only from the option we can say the normal component. All the boundary conditions for electric field is Hn1 minus Hn2 is equals to K, or you can say if it is dielectric, nothing is there. Ht1 is equals to what? Ht2. Bn1 is equals to what? Bn2. These are the magnetic boundary conditions. Electric boundary condition, Et1 is equals to Et2 and Dn1 is equals to Dn2. From the option we can say that the B option is correct, because he is asking for the complete electric field. Complete electric field is not constant, only the tangential component is constant. Magnetic field, in magnetic field only the magnetic field tangential component is constant, not the complete magnetic field, right? Which of the following is the primary purpose of inverse FFT? Inverse FFT means whenever you have a DFT signal, you are calculating the inverse of that signal. So to come back from the frequency domain to the time domain, decompress the time domain signal, reconstruct the frequency component from the time domain, convert the frequency domain signal into the time domain signal. So basically whenever you have a IFFT means you are going from the frequency domain to the back into the time domain. The nodal analysis, the number of node to be considered for a KCL equation is equals to the, okay, in the nodal analysis the number of node to be considered for a KCL equation is equals to, see basically if you have a you have a network like this, let us take, we have a resistance here, we have a resistance here, we have a battery here, like this. So basically we have two nodes inside this. So every time whenever you apply the nodal analysis, you have to choose one node as a reference node. If you have total number of principal, see there are two types of nodes, simple node and principal node. Generally we are using the principal nodes, simple node we are not considering inside the nodal analysis. When you apply the nodal analysis, you have to find the principal nodes, and from out of the, let us take, if we have two principal node like this, out of these we have to assign one principal node as a reference node. So remaining one node we can apply the KCL. So generally if your system have n principal nodes, so out of these n principal node you have to assign one node as a reference node. So remaining n minus 1 nodes, total node minus 1 used for considered for a KCL equation. So answer will be B. The reason of convergence of a Z transform for which the following discrete time sequence is not greater than. See basically if you take the Z transform of this impulse signal, out of these all have the mod Z greater than equals to 1. See if you take the Z transform of this impulse signal, the Z transform of impulse signal is 1. Remember, and what is the ROC? ROC of this mod Z, ROC is entire Z plane, ROC is entire Z plane. So it will not bound by this mod Z greater than 1. What will be the answer? C. When you take the Z transform of an impulse signal, the Z transform of an impulse signal is 1 and its ROC is entire Z plane, so it will not be bounded by mod Z greater than 1. So what will be the answer? C will be the answer. How many T states are required for the opcode fetch cycle in a 8085? So whenever you have a 8085 microprocessor, there are opcode fetch. Opcode fetch means you have to go to the memory and you have let us take you write something like this, we have to add. So when you write add, so it will go to the memory and that location where the add instruction is available, it will fetch that. So basically the process is called as opcode fetch. So whenever it is fetching the instruction from the memory, that is called as opcode fetch. So opcode fetch required how many T cycle? That will be 4. So whenever you have a 8085 microprocessor, opcode fetch required 4 T state, right? Okay, the Bode plot, how is the order of the system is determined from the phase float. Whenever you have a phase float, you generally count how many phase crossing. Phase crossing means how many time it is crossing the zero axis. When you can count the phase crossing, number of phase crossing is equals to the number of order of the system, right? It is equals to the order of the system. So by counting the number of phase crossing, you can check that what is the order of the system. Okay. Next one is the length of a linear convolution of a two sequence of length m and n. See, if you have a time domain signal, first I am discussing about the continuous signal. You have a 1 to 3 and you have another signal, let us take 2 to 4. So basically when you are doing the convolution of this signal, the resultant signal will be from 3 to 6. So the range is become how much? That is become 3. So basically this has the range 1, this has the range 2. So they will add, this is 2, this is 1, that the range become 3, right? The difference between these two. So in continuous domain, whenever you have two signals, they are convolving. The first one has length L, second has length M. So the length will become L plus M, but not in case of discrete time signal. If I am talking about the discrete time signals, you have first signal whose length is L and you have second signal whose length is M. So generally in discrete convolution, I am again repeating, whenever you having a sequence means discrete convolution. Whenever you have a discrete convolution, it means the length will be L plus M minus 1. Number of elements in first sequence plus number of elements in the second sequence minus 1. In case of discrete, in case of continuous, it will be added of these two signals, right? That is the main thing. Okay, asynchronous counter the flip-flop except the first the trigger by. See, whenever you have a asynchronous counter, so what is the main thing? That is a ripple counter, every synchronous. So output of the first flip-flop will work like a clock for the second flip-flop. So that is the main thing about the asynchronous counter. In synchronous counters, what happen? Each flip-flop will be triggered with the same clock, but in case of asynchronous counter, each flip-flop will be triggered by the output of the previous flip-flop. So the output of the preceding flip-flop. What will be the answer? The output will of the preceding flip-flops. Okay. The 10 volt stabilized power supply required to be produced from a 12 volt DC power supply input source. The maximum power rating of a Zener diode is 4 volt. Means the Zener diode can handle the maximum power 4 volt. The maximum power that can be handled by a Zener diode, it is 4 volt, right? And calculate the maximum current through the Zener diode. See, basically, if it is stabilizing 10 volt means it is providing a constant output of 10 volt. When you are applying a 12 volt DC supply, it means your Zener diode like this. Let us take your Zener diode like, not like this. The Zener diode, you have a Zener diode here, like you have a resistance here, we have a 12 volt battery here. So it will provide you with a constant voltage of 10 volt here. So basically the voltage across this Zener diode is 10 volt, and power, how much maximum power it can absorb, that will be 4 volt. So how much maximum current? The current maximum is what? Power, because power is always equals to V into Z. So maximum current is equals to what? Maximum power divided by the voltage across the diode, that is 4 divided by 10, that will be 400 milliampere. The answer will be C. So basically you should remember, whenever you have a Zener diode circuit, you can solve like this. The Zener diode is specially designed to operate in reverse breakdown region. You remember that thing, there are two types of diode. One is normal diode, another one is Zener diode. Zener diode is always work in reverse bias. In reverse bias, after the breakdown voltage, if I draw the characteristic of a Zener diode, the characteristics are look like this one. In the forward bias, your Zener diode will work like a normal diode, but in the reverse bias, what happens? Whenever the voltage across the Zener diode is exceeding the voltage, breakdown voltage of that Zener diode, VBR, then what happens? The current through the Zener diode will change, but not voltage across the Zener diode will not going to be changed. So basically, generally, if we are not using the Zener diode in the forward bias, why we need Zener diode in forward bias? Because we have a normal diode, we can use that one. We generally use the Zener diode in the reverse breakdown region to get a constant output voltage across the Zener diode. See, integral form of Faraday's law says that the closed line integral of electric field means this represents the potential. Potential is always equals to the rate of change of the magnetic flux minus d upon dt means rate of change of the, this is called magnetic flux. So it is what it is saying, the electromotive force around the closed loop is equals to the time rate of change of the magnetic flux through the root. See, basically voltage means electromotive force. So this E dot dl represents the electromotive force. So what will be the answer? Answer will be the C. See, this is the Faraday's law. The last question, the monostable multivibrator IC IC 555, if the resistor R is 100 ohm, 100 kilo ohm, that will be 100 kilo ohm, and the capacitance is 10 microfarad. What is the pulse width of the output? See, basically if you are dealing with monostable vibrator, in case of monostable vibrator, the time period is 1.1 into RC. So all the values are given to you. You can plug in the values. You will calculate that the time period is going to be 1.1. So these are the all question which is the past exam for the BEL. So basically, if you are trying to focus on this exam, you can join the YourPedia. So on the 15th of January, our courses are going to be launched and we are going to be taking the live classes regarding this. See, it is you can say it is different from the gate because lots of the theoretical questions, lot of the parts which will not covered in the gate, right? There is a lot of things. There are satellite communication, line of sight communications, lots of things are there. So basically, if you are trying to prepare for this exam, you can join the YourPedia module. Thank you.